me say it one more time. If you go to Canvas, go on Pages, there's a practice test 3. The first side's related to quiz on Thursday. I've got a video on YouTube that's not a solutions video, but it does talk about each problem. And then I have the actual solutions I'll post later today. Ah, okay. Any questions on that? That's neat. Okay. All right. So what do you guys, did you guys see my email there when I did that? Oh, well. Or am I back to Canvas now? I don't know how this works. All right, somebody help me out real quick. What do you see right now? What's the title at the top? Anybody? Can anybody tell me what they see? Quiz 3 corrections. Oh, okay, I see. Okay, so you see the hypothesis test for one sample mean? I like it, thank you, thank you. So you were just looking at my email earlier. I love it, and that's all right. I ain't got nothing special in there. Let me see. So let's come out of this. I'm gonna stop sharing. This is what we're gonna talk about here in a bit. It is up on Canvas. I'm gonna come out of there. Oh, thank God. All right. Oh, every day is an adventure. Okay, all right. Let me turn off Tatooine. Sorry, Tatooine. Got to turn you off. Oh, okay. So I got some more light fixtures in here. Hoping the light's better. All right, guys. First off, before I jump into everything, any questions from homework or questions from anything? To be honest, what we've done so far, you could start chapter 9 homework. Let me say this. The way that chapter 9 homework works is that you don't have complete hypothesis test problems until section 9.5. 9.1, 9.2, 9.3, 9.4 talk about parts of the hypothesis steps. There's 5 total steps. In chapter 9, stay with me. Let me know if you have any questions as I go through all this shit. In chapter 9, they reference a worksheet in the back of the book to use to do the problems. Screw that worksheet. You're going to use the 5 steps that I talk about because they do the same steps. They just do it in a weird order because they let the calculator do all the work. And unfortunately, you got me. And I make you do the freaking work. It's too bad. All right. Everybody with me? Anybody have any questions about that? Okay, so I'm about to launch into where we left off last time. So let me know right now if you have any questions. No, okay. So here's where we got last time. We actually got through, if I remember correctly, we got through the first 2 steps of a hypothesis test. We did, believe it or not. So here's an example, just to remind us of where we got. Oh, this kind of sucks. Here's somebody else. Bam, come on in. Let's say that somebody claims they can, what do you want to say, Jeff? Oh yeah, this is perfect. Have you ever seen those jars and you have to guess how many jelly beans are in the jar? You know what I'm talking about? Or how many rubber balls there are, whatever the hell, right? Okay. So if you haven't, there's a jar and there's a bunch of jelly beans in it. And if you guess how many there are, you get your name up on the wall. It's a great honor. So let me see. In fact, let's do it like this. Yeah, something like that in 3rd grade. I love it. Let's do it. Let's make it even better. Let's say that there are several jars with jelly beans in them, right? And one guy says, I'm going to guess, I think the average of the jelly beans in the jars is 347 jelly beans as an average. Is everybody with me? Now listen, if you averaged all the jelly beans in all the jars and it was 350, would you go, oh, you suck. You were so wrong. I mean, if the average came out, I mean, like, holy shit, dude. Either you're really good at something or you were there when they packed it, or I don't know. Are you guys with me? That would not be evidence that he was wrong. Do you understand? Do you see the difference? So if somebody guesses, oh, I think it's 347 per jar on average, and the actual average is 350. Do you see how that's good, isn't it? You go, wow, pretty damn good. Are you guys understanding what I'm saying? I mean, you don't have to. Yes, okay. So there's a bit of a wiggle room. If you guess somebody's height is 5'10" and they're actually 5'10.5", all right, that's pretty good. But if you guess their height is 5'10" and they're actually 4'7", you suck. So it's an idea about how far away something is. I like it. So to be honest, let me ask you this. In general, if the mean was 347, could you really say if 360 is that far away from 347? What do you guys think? Is 360 far away from 347? I'll tell you the answer. Let me see if you can tell me why. The answer is I can't say. I have no freaking clue. That's the answer. Just in general, if the mean was 347, is 360 very far away? There's something missing that I can't tell in general. Yes. If the standard deviation was 13, right? Stay with me. If the standard deviation was 13, how far away is 360? One step. It's just one step away. And that's pretty damn good. One step away is not even anywhere near unusual yet, right? Okay. But if the standard deviation was 1.3, now that is 10 steps away. That is insane. Meh. All right, Alex. Some people, I just can't. All right. You guys, so that's what we talked about that idea before, but now what I love about chapter 9 is it's that idea really blown up. And then you see how important it is. This is why I made a big deal out of chapter 6, where we introduced z-scores and really started working with them, because that's how we measure distance, which is how we tell how far away something is from something else. And that could be evidence of something being right or wrong or something. All right, let me take this away. So coming back to the jelly beans, let's get more specific again. Let's say that we take a sample and we find, actually, wait a minute. So he claims the mean is 347. You with me? So don't answer that question. Just tell me if you're not with me. Do you guys remember what these two are? We talked about these two guys here. That's actually like an H1, but it will. Right, the null hypothesis and the alternate hypothesis, affectionately known as the ho and the hi. Does somebody remember where this statement would go? Did we talk about that last time, actually? Let me see. I talked about what these two were. I'm pretty sure I must have talked about, maybe not. Not too much. Okay, let's get into it. The way I want to set this up is here we go. Here's the idea. Ready? Here we go. So say this problem, I know it's normal. Just give me a break here. I got to talk about one thing at a time. What would be evidence that it isn't 347 is, what would be evidence that it's not 347? So the average really is 347, and I take a sample. Where should that sample be if the average really is 347? If I take a good sample, where should that sample average be? Would I expect it to be over there? If I take a random sample, the sample average should be close to the mean. I love it. That's exactly the right phrase. Kick ass. Right? So I would think that if this is the right mean, that when I take a sample, that the sample mean would be close to that. And again, what measures closeness? Z-scores, right? Oh shit, somebody's coming in. Gotta open the door. Hold on. There. All right. Now, stay with me. Stay with me. So where would my sample have to show up to be evidence that it's not 347? Not proof, but evidence that it is not 347. Yeah, outside usual, I think is what you mean, right? So if I got a sample down here or up here, either way, that isn't proof, because is it impossible to get a sample out there if that's the real mean? No. But is it unlikely to get a sample out there if that's the real mean? Yes. So if I got a sample, let's say I got a sample up there, right? Let's say I take a sample and I take the mean and I get it way the shit up there. That would be evidence that the real mean is bigger. So what we do in a hypothesis test, I think, is we assume that the number we're given is correct. And we say, okay, great. Let's say that's the middle. Look what I just did. So it's like, if that is the real middle, any sample I take should very likely be in here somewhere. If I take a sample and it's outside of there, that is evidence that that's not the mean. It's more likely that the real picture looks maybe like that. Then that sample I took would have been more likely. Then it makes sense that it happened. What's the chance that we're wrong? Well, that's the area in that tail. That's the likelihood that that sample could happen. This is really cool shit. So we can actually directly control the probability that we make a type of error, that we say that it isn't really 347 when it really is. We can control that error directly. And we'll come back to that. It has to deal with, remember alpha? Okay. So the heart of hypothesis test is all about setting up the benchmark for where evidence starts and then seeing where my sample falls. Is it enough evidence? Beyond a reasonable doubt. There's a really good connection between what we're doing here and court cases, right? What's the null hypothesis in a court case? Innocent. What's the prosecution trying to prove, show evidence for? Guilt. Maybe, okay, all right. And we actually never proclaim somebody to be innocent, do we? You cannot prove that somebody is innocent. You cannot. What you do is you do not find enough evidence to say that they're guilty. So they're always pronounced not guilty, which does not mean innocent. Nifty. Okay, enough of that shit. All right. So help me out. So here's the idea. I always want this one, no matter what the shit the claim is. I always want that one, the alternate hypothesis, be the one that I can show evidence for. I can never show evidence that a mean equals something by just taking a sample. I can't. In fact, let me do this. I forgot, I should have done this first. This is a beautiful place to put this, by the way. So don't, I'm gonna pretend like that's true. Let me see, where did I put you? There you are. You guys, most of you guys did that T-score practice sheet, right? I kind of want to show you the nifty results. And this is not a bad place to do it because I can make a point out of it and pretend like I meant to do it this way. So here, let me show you this. Can you guys see an Excel spreadsheet now? I don't trust this thing. Yes, okay. So now watch. This is kind of cool. If you did that sheet and you turned it in, one of these little intervals is your interval, right? So these are all the means that people got, and these are all the standard deviations that people got. I can expand this so you can see. Anyway, all right. Let me stop for a second. So that was that T-score practice sheet that I asked you to do. It was due yesterday evening, I can't remember. And most of you guys did it. I think most, maybe a little over half. But here's the neat thing. So somebody got an interval from 75 to 85. Do you see that in the beginning, or 86 almost, right? No, and if you remember, the last question on that sheet was, is there evidence that the mean is 80.297? And that was the real mean of all those data points. Did anybody get 80.297 as a sample mean? Of course not. We're not surprised about that, are we? If you take a sample, will the sample mean be the same as the real population mean? I can almost say no. Is there a chance it could be the same? Yeah. Same chance that you get hit by a meteorite and lightning while winning the lottery. I mean, so it's maybe not that impossible, but it's pretty unlikely that you take a sample of size 20 and you get the exact same mean as all those data points. Does anybody not understand what I'm saying right now? So this, let me connect this to what we're doing with the hypothesis tests. Oh yeah, it's true, Alex. Yeah, I know. Yeah, those are always interesting. Like, oh, there's one coming. What was I saying? Shit. Oh, hypothesis test. I can never prove using a sample that the mean, the population mean equals something because of what I just said. The sample mean could be close to the real mean, but it's never going to be equal to the real mean. So I can't prove or even show evidence that a mean equals something, which is why I worded the last question on that the way I did. I can show evidence that it doesn't equal something. And if you look at the spreadsheet, do you see the two that are in red? Let me put these in bold. Bold. These two, if you notice, if you recognize those intervals, 81 to this, 81 to this, you did nothing wrong. Hear me, hear me. Hear me now. You did nothing wrong. Inherent in making a 90% confidence interval, what chance is there that my interval does not catch the real mean? What's the probability that any interval created, a 90% confidence interval, will not catch the real mean? 10%. Kick ass. 28 people turned this in, right? Which I guess is more than half, yeah. Where's the rest of you? Nah. Anyway, I'll stop. All right. 28 people turned this in. What's 10% of 28? 2.8. And do you see how many red ones are there? 2. That's not bad. So on average, I would expect 2.8 confidence intervals constructed by 28 people to not catch the real mean. And I got 2 of you. And there were like 3 other ones that were really close to not catching it, right? You guys, that's kind of cool. I don't know if anybody sees what I'm saying. That was really cool. Do you see how long it took? I'm looking at them like, damn it, everybody's getting it, damn it. And then finally, right at the end, 2 of you right at the end didn't catch it. All right, maybe. So I expect almost 3 to not catch the real mean. What did I actually see when we did this experiment? You guys picked the frickin' numbers. I didn't pick the numbers. You picked the numbers. And sure enough, 2 did not catch. That's really close to what I expected. Anyway. So the thing I want to get from this for hypothesis tests is I cannot prove a statement about mean equals something. Let me come back. Oh, I cannot prove a statement about the mean equals something because any sample I take, its sample mean will more than likely be different somehow from the real mean. But I can show evidence that the mean is different, greater. Like if I get up here, that's evidence that the mean is actually bigger. If I get down there, that's evidence that the mean is actually smaller. Because it's not where it should be if the mean is that. Okay, maybe. So if I didn't say this last time, pay attention. You write the claim down if it has some kind of equal sign, either equals, less than or equal to, greater than equal to. If it has any of those, anything where it's possibly equal to, it goes in for this old guy at the coffee shop. It goes in for the, you put it into the null Hypothesis, right? Or the HO, whichever way you want to refer to it, right? I'm always curious if my dean ever watches these. Jeff, you're talking about HOs? All right. So what's the opposite of what that guy thinks? That goes into the other guy. What's the opposite of equal to 11? Why did I put 11? Somebody should be like yelling at me. 11 was the number I used yesterday. This is 347, right? Why didn't nobody, everybody's like, sounds good. 11's almost 347. I'm sorry. That's the number I used yesterday. I have no idea why that came in my brain right there. So the claim is mu equal 347. We put it here because it has an equal sign. And now the H1 is mu not equal to 347. I can show evidence for that statement, right? I could show evidence for that statement. I know right now this seems like a lot, but all we just did right now in that first, this is going to be the first step in a 5-step process, right? Ooh, that sounds great, Jeff. You write down the claim. If it has an equal sign, you put it there. If it doesn't, you put it there. And then the other one is the opposite. That's all. All right. Second step we got into last time. Let's say that we take a sample of 41 and we get, and we know that, sure, we get X bar equal to 340 and S equal to, what do you got, Jeff? 21.97, sure, all right. I don't really want to make this too detailed, but what the hell? So the second step really is, am I allowed to do something, and what is it that I'm allowed to use? So what do I check to make sure that I can do something, What has to be true before I can do something? Okay, I like it, Ree. So it's got to be normal. Is it normal? Yes, n is greater than 30. Chicken, lettuce, tomato says do it. What do I check now to tell if I use a Z or a T? Yes, in which standard deviation do I know? I only know S, therefore, I think somebody already said it, I have to use T-scores. Okay, maybe. So that's the first 2 steps. I want to make this a little more organized. So I just want to remind, that's how far we got last time. I'm pretty sure we did the first 2 steps, at least, last time. All right, could you please repeat why we use T again? So again, if it's not normal, I can't do shit. So the first thing I check is it normal? Now here I was twice over. I said it was normal to begin with and the sample's bigger than 30. So either way, we're good to go, right? Why were T-scores invented? Because somebody drank too much Guinness. No. Why were T-scores invented? To cover our ass from when we don't know the population standard deviation. Central limit theorem. CLT is central limit theorem. And that came from chapter 7. I like it. Remember, that's where we have to change the standard deviation divided by the square root of n, that kind of thing. But it says if n is greater than 30, then it's normal enough. That's why I put a little CLT there. All right, coming back to Z and T. T-scores were invented from when I only know S, when I don't know the population standard deviation. That's why they're invented. So how do I know when to use a T-score? When I only know S. Why can I use a Z-score? When I know sigma, right? Maybe. That's it. That is it. All right, so you check if it's normal, whatever the appropriate check is, and then you say, do I know sigma, Z-scores, or do I only know S, T-scores? That's it. like it. How creepy can I get? Yeah. All right. Okay. Not seeing anything else. Moving on. So I'm gonna transition to another sheet here, so I can turn around. Oh. All right. So, where did I put you at? Boom, bam, boom. There you are. Let me blow you up, and then let me share my screen. O'Reilly. No idea. I love it when I get freaking commercial jingles in my brain. All right, so everybody sees this. I had this up earlier. Oops, somebody's chatting with me. Hold on. Come on, give it to me. There you go. That was creepy. Auto. Yeah, thank you. I have no idea. Who knows? Okay, so let's take a look at this. Can you guys just try to do the first step? Read through that problem. And again, this is up on Canvas, but you can see it right there too. Let me know if you have issues seeing. I can actually zoom in a little bit. Ooh, I can zoom in a lot. Oh, yeah. All right, wait, zoom back. Okay. First step in this, just like, I don't want to bring back any traumatic experience, but just like in word problems in algebra. Oh, this is not what this is. This is not a word problem. It's just a bunch of numbers hidden between words that you have to use correctly. So it's not a full-blown word problem. But the first step is not mathematical. It's the same step in word problems. The first step is not mathematical. It is English. What is the claim that somebody is making? And then I translate that into math. Can you guys see the claim that somebody's making? Is anybody making a claim? If not, we just, we don't do this sheet, but somebody is making a claim, so don't get too excited. Anybody? Is somebody believes something, which is a claim? So no, so watch. Yes. The second sentence, it says mean lifespan of all coyotes in captivity is 10.15 years. That's not a claim. That's a reality. That's just a known fact. I'm giving that as a known fact. A researcher believes that coyotes live longer if they're given more room to roam. So his claim is that these coyotes live longer than 10.15 years, right? So in English, I'll type it in the chat. In English, the claim is these coyotes, get in there, live longer than 10.15 years if given more room to roam. No, you don't spell roam like that, Jeff. There you go, buddy. All right, is everybody with me? You actually don't have to write that somewhere, but it's not a bad idea. You could write it down. And now I want to translate that into, in fact, I should have been more careful. On average, right? Their average length of life is longer than 10.15 years. So how do I write that in mathish right here? I can't make a mu symbol, so I'm just going to have to, no, be careful. Okay, here we go, everybody. This is really important. All right, let me see. There's a lot going on here. I'll tell you right now, how does things work in science? Do you have data and then you make a claim? Or do you make a claim and then go get data? And everybody's like, we don't know. Yeah, we have a claim. It could be based on who knows what, but then we go get data to test the claim. So the sample information will not show up until the fourth step. That's where we start to actually do the analysis. So the claim, let me just write it down here for us, is that I'm going to write mu instead of, I can't make a mu symbol. The claim is that mu of these coyotes is greater than 10.15. You see, if I do this, is that still all right? Yeah, that fits better. Let me stop for a minute. Is anybody not with me? So the claim is that the average life of these coyotes is longer than 10.15. So that's what it looks like in Mathish. I'm not sure where to point for you guys, but it's over there for me. All right. Okay. So where would that go? HO or H1? Oh, wait. So you ask yourself, does it have an equal sign? In fact, do you guys notice one of the main points of this sheet? This is a really good sheet to have sitting next to you. Hi, Laurel. No, I know what you mean. This is a really good sheet to have sitting next to you when you're doing this homework, because these are the questions I want you to answer. But also, do you notice how right here I've got explanations? So just to remind you guys, the null has to have an equal sign. Does that statement have an equal sign? No. So it doesn't go here. It goes here. It doesn't have an equal sign. Yeah, so I'm going to put this statement. Let me see if I can do this. I'm going to put that statement. Well, you have to do this, Jeff. There. All right, good. Right? And again, I mean, I want you to go into this understanding why that is. I always want the statement that's there in the high to be the one that I can show evidence for. And I can never show evidence for something that thinks something equals something. There was a lot of somethings. So what would the null be? What would the hoe say? The cow says, moo. The hoe says, eh. What would the statement that goes into the null hypothesis be? What's the opposite of, well, I'll tell you what, the books sort of goes, every now and again it says it's always equals, but what's the opposite of greater than? Less than or equal to. Right, you guys cool with that? I can't make a real less than or equal to. Aw, thanks for playing, Malachi. So the opposite of greater than is some kind of less than, but it also includes equal to, because the two together have to cover everything. So if one of them is not equal, the other one has to have an equal in it to be truly opposite. All right, let me stop for a minute. How do you guys feel about that so far? Anybody have major issues with that? All right, now think about this. Let me try to draw this real quick. Well, let's do this. Let's do this. Before I answer this question right here, because we're not used to this question yet, let's go down here real quick so that I can draw the right picture up there. Just go with me for a minute, and you'll like, that's all we ever do, Jeff. Can we use z-scores, t-scores, or nothing? So what is it that tells me I can do something? What is it about this problem that tells me I can do something? Christopher is like, please tell me we can't do anything, Jeff, and let me go back to bed and just stop this shit. And, all right. Yeah, why do I know it's normal? Did it say it was normal? Yeah, there we go. N equals 41. I like the number 41. I don't know, greater than 30. Right, so that's the good old chicken, lettuce, tomato. Or more officially, central limit theorem. Right, that says normal enough. It says go for it. But now, what is it I can use? What do I check to see if I use Z or T? What tells me? Yeah, why Z-score? It's definitely a Z-score because which standard deviation do I know? Population standard deviation, right? Oh. If you can't tell, it's almost definitely a sample standard deviation. If it was a population standard deviation, I'm going to shout that from the rooftops because that's an awesome thing for a statistician to have. Like, we know something? Shit. We normally don't know shit, right? Not because we're dumb. Well, sometimes because we're dumb, but because we just have enough information. So yeah, I know sigma. No, Jeff, I know sigma. So therefore I can use z-scores. Yay. Okay, how are we all doing? So let me come back. I know now that it's normally distributed. So let me go ahead and draw that picture. I don't want to draw this picture until I showed you why I could. Wow. Sorry, that's a very good one for me. I get excited about little things. Can somebody tell me, please, think about it for a second. You always look at H1 to see where the evidence has to be. Where would the sample have to be to show evidence for H1? Look at what H1 says. So we're going to assume that the mean is the 10.15. We're just going to assume that. On the right. Yes, I love it. So to show evidence that it's not 10.15, my sample would have to show up out here somewhere. Right? Because we think it's greater than. So of course, if I got like a sample of 9, I'm not even going to do the test. I'm going to stop right there and go, shit, maybe I'm wrong. More likely, I'm going to just take a bigger sample if I really feel confident about what my hypothesis is. You guys with me? So is that a one-tail test or a two-tail test? Now it's pretty obvious. It's a one-tail test. I just made one tail. It's all, the sample has to show up above. It's one tail. Now you understand why the t-score chart has a one-tail row and a two-tail row. It really is built for hypothesis testing. Confidence intervals just kind of luck out. They're like, we're two tails. Oh, okay, good. I can find you guys. Okay, maybe. All right, coming back down here. So it is a one-tail test. One tail. Okay. A one tail. All right, coming back. Now watch. Okay, so remember, why can't it show up on the other tail? Because, Lewis, if it's, again, to be on the other tail means the sample I get is less than 10.15. Is that evidence that the mean is greater than 10.15? No. Right? So somebody said, I think the average age at Grossmont is 27, and we take a sample of 100 in our average, I'm sorry, let me say this again. Somebody claims that the average age of Grossmont is more than 27, and we took a sample and our average is 24. We don't have to do anything. We're like, that doesn't prove what you said. It doesn't prove they're wrong, but it is definitely nowhere near. It's just shit. It's not evidence at all that they're right. So that's why it's a one tail. There's only one direction, not the band, that will help me show evidence for H1. That's why it's a one-tail test. So part C is going to make this a little more formalized. We're actually going to define where the hell that is. And look, what's the most important thing I tell you in part C? And by the way, this is called the rejection region. We'll talk about why in a minute. But it's going to be up here, right? We already determined it's going to be up there. What the hell does this mean? What the hell is that? Please tell me I'm recording. Yes. Where's it at? Oh, we'll get there, Alex. We'll get there. We'll get there. It doesn't mean anything about friend zone or anything. Nothing about confidence intervals here. Careful. This is not a confidence interval problem. Right? It's not a confidence interval problem. Alpha is the area in the tail or tails. So alpha is 0.01. So this is going to be, oh crap, get out of my way. Why you gotta be so this is 0.01. All right, let me stop for a minute. We know that, right? Remember alpha, the little fish dude, is the area in the tail or tails? We're just so used to confidence intervals being two tails. I understand, but this is not a confidence interval problem, right? This is a hypothesis test. Now, let me tell you. What did we say we could use, Z or T? We said we could use Z scores, right? But I'm going to look at the T-score chart to find what I want. Is that insane? Did I already tell this class about the bottom of the T-score chart? If you look at the bottom of the T-score chart, yeah, thank you, Ree. You see Z-scores, which only makes sense. The bigger the sample gets, the less I need a T-score, because I know this is a lot, but the reason T-scores exist is because S is not a good estimate for sigma unless the sample gets large. So when my sample, you gotta love this shit, is large, I can use z-scores. Get down there. So this is a really cool sheet. I want you to really get this. If you use this sheet and stop, you get a t-score. If you go all the way to the bottom, you get a z-score. Malachi, what's up? You're muted. Are you trying to talk, Malachi? What's up? Can you unmute? Yes, okay.
Oh, okay. I unmuted it. Are we trying to prove H1 or disprove it?
I can barely hear you. Hold on. Let me see. Is it my volume? No. What do you say it again?
Are we trying to prove H1 or disprove it?
I love it. Okay, you ready? Can't prove shit. We're trying to show evidence for H1 or not find enough evidence. So it's just like a court case. Do you have to prove you're innocent in a court case? No, you don't. In fact, if the prosecution sucks, the defense doesn't have to say a word. We're like, it's on you to prove he did it. So in this, we're always trying to show evidence for H1. Always. That's why we put the thing that has an equal sign up here, because we cannot show evidence for equal something. I like it. Love it. So let me see. It's a one-tail test. Alpha is 0.01, and I can use z-scores. One-tail test. Alpha is 0.01. So I'm looking at the second column, and I can use z-score. So go all the way to the bottom. Oh, shit and a half. Let me see it. There it is. There it is. 2.326. Questions? So I told you guys back when we learned what unusual was, I said later in the course, we're going to change the definition. What am I drinking? We're going to change the definition. The United States. All right. We're going to change the definition of unusual depending on the situation we're in. So in this situation, alpha equal 0.01 tells me where unusual starts. And where does unusual start? 2.326. So here I'm going to kind of re-say a few things I already said. If the mean really is 10.15, then the sample that I take should show up in here. If I take a sample and it shows up in here, I can reject shit and a half. I didn't mean to do that. All right, got it. I can reject the null hypothesis, or more inappropriately, I can say I can reject the hope, right? So that's why we call this the rejection region, because if my sample gets in there, it's so damn far away from what the null hypothesis thinks that I can say it looks like the null is wrong. The null thinks it's in here, right? Because it thinks it's equal to, or in this case, even less than. But if I get way the shit up there, it looks like that guy's wrong. All right, moving on. So real quick, do you see how I say put it into words also? So the way I put this into words, just put this into words. There's so many parts of this. Do you see 2.326? That's a z-score, right? 2.326 is a z. Oh, how did I get 2.326? Again, alpha is 0.01, it tells me. It's a one-tail test. We figured that out earlier. And I want a z-score. So alpha is 0.01, one-tail test. One-tail, 0.01, so I'm in the second column. And I go all the way to the bottom to get a z-score. So I get 2.326. Bam. So that's a z-score, right? Yes. The next step I'm going to do is I'm going to get a z-score for my sample and see where it falls. So step C is, here's where evidence starts. And step D is, did I find enough evidence? Where's my sample at? So I'm going to make two z-scores. One is defining where the evidence starts, and the other one is from my sample. So I call the one down, see this? I call it z star just to make a distinction, right? So that's why I call it z star. That's actually my own creation. Is it real? I don't know. So z star, if the z-score I get from my sample, which I call z star, if that is greater than 2.326, we can reject the hoe. Which means, oh boy, where did I go? Which means if I can reject the null, that means that I can support the high. I just said the same thing twice. Right? If I say this one little dude sounds like he's wrong, then that must mean the other little dude sounds like he's right if they have opposite viewpoints. All right. Okay. And so to tell you the truth, the third and fourth steps, C and D, are the heart of the hypothesis test. Where does evidence start? Did we find enough evidence? That only makes sense. So part C is, where does evidence start? In this case, 2.326. Part D is, how far did our sample get? Did it get far enough away to show evidence that the null is wrong? So part D is going to be very, 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 very familiar. Let me see. I don't know if everybody has this handout, but can you guys all see the sample information? Now you bring in the sample information. So for example, I know the sample mean is 12.45. Man, I really hope can somebody hit the yes button? I'm really hoping that I am still with you. Yes, thank God. Okay, my Wi-Fi was freaky earlier and I think I got it fixed. Let me see. Here. So the mean is 12.45, right? The sample mean is 12.45. N is 41. Population standard deviation is 4.27. Let me write all that shit down. So the X bar, why did we use the t-square chart? Oh, okay, so Malachi. Short answer, z-scores live at the bottom of the t-score chart. Longer answer, why? Because the bigger my sample gets, until it gets to large, the more I trust S, the better S estimates sigma. So the less I need t-scores. So when my sample gets large enough, I can just use a z-score. Sweet. So the short answer for that was z-scores live at the bottom of the t-score chart. Not in a pineapple or something. All right. Oh, no, stop. X bar, now I forgot, was 12.45, is that right? 12.45, I'm pretty sure. Yeah. Yeah, and then sigma was 4.27. Did you really just forget that, Jeff? 4.27, I'm pretty sure that's right. No, Jeff. I can spell sigma right. I'll think about it. Sure. You got a sign, Mal. And N was 41. Right? I like it. I like it. Can we stop for a minute? Yeah, that's right, Christopher. I don't know. Cool. And then I give you some pointers here. Again, I'm not going to do this all the damn time. This is the one sheet I'm doing this on. So this step tells us how far away our sample is. And then I get a more practical thing about you got to get the new standard deviation, right? Because we took a sample. So the new standard deviation would equal the old one divided by the square root of, where do you go, 41. Man, I don't know. For some reason, time just goes by quick. Right? That should be old news. I'm trying to find a z-score, so I got to change the standard deviation because they took a sample. And if I do that, I get I almost get something evil. I get 0.667. So when I do the z-score formula, my z star is the same old formula. It's going to be my data point, 12.45, minus the supposed middle, 10.15. Is that right? Yeah. Divided by the new standard deviation, 0.667. And I think I did this the other day, 2.3 by 2/3. I did it yesterday. Darn it, 6.9 divided by 2, 3.44. That sounds right. Because nobody's helped me. Thanks a lot, guys. I'm hoping that you'll speak up if I've run past your understanding on something. 3.45? All right, I can live with that. Now watch. We already know by itself. Is that a big z-score? Is that like a really big z-score? 3.45. You could do it. You could do it. Hell yes. Now in conjunction, now be careful. We kind of compare it to 2 because we're so used to. But in this case, unusual was defined to be 2.326. Did we beat that? In fact, let me change color here. Let me see. Oh my goodness, Jeff. How do you do that again? Oh yeah, here we go. So didn't we make it here? In fact, I could put a little star. Can I? Sort of, sure. That's a star. Why not? Hell yeah, we beat it. So what does that mean? That means that it looks like the guy who thought it could be equal to 10.15, who thought it could be in here, it looks like he's wrong. What's the chances I'm wrong? 1 frickin' percent. Shit. That's pretty good. So right here we can say that we reject HO, which means that we support H1. All right. So I got like 5 minutes. This is good because I didn't really get to the conclusion for my last class. I actually want you guys real quick. I know it's almost time. But, oh well. Let me see if I can. Oh yeah, it's right. It's right here, Jeff. Bam. All right, just real quick. This is the last thing we'll do, obviously, right? This sheet is also up on Canvas. Can you guys do the first step for me on this problem? This is a problem about forward focus. You guys see the one about forward focus? I think, do they even make those anymore? I don't know. I had a forward focus for 7 years and it died a horrible death. Poor little thing. Was it 7 years? Something like that. Try it out. Do that first. Do 1A. Just do 1A for me. Just try it. Do something. Make mistakes. Why not? Get them out your system. This ain't graded. I ain't looking at what you're doing. Where am I? I bought the advanced zoom. I can see everybody. So this one might be a little bit hidden, but can somebody see what the claim is? What sentence does the claim live in? First, second, third, fourth? Which sentence is the claim in? The second sentence has the claim. The chalice from the palace holds the brew, which is true. I don't know if anybody knows that. Anyway, sorry. Second sentence has the claim. And what's the claim that's being made? What's the claim in English? The claim is the average assembly time is the same as the overall average, which is 38, right? Yeah, which number would not show up until the fourth step? 37.3, right? That's the sample stuff. That doesn't show up until the fourth step. That's where the sample stuff comes in. So our claim, geez, Jeff, don't yell. What time is it? Oh, shit, it's just about time. Hold on. Our claim is that mu, the average time at this assembly plant I'm going to, our claim is that their population average is the same as the general population average. We're just sort of quality check, right? Are they worse or better than 38? If they're worse, if they're better, we'll see what's going on. So where's that gonna go? See, so my first thing I think about is what's the claim in English, translate it to Mathish, step back and say, does it go into HO or does it go into H1? Yes, Malachi. It's got an equal sign, so it goes into HO. It's that simple. Because it's got an equal sign, it goes into HO. The null hypothesis, I love it. So this one is going to be mu, damn it, do I have a way? Not here. Oh well, too bad. Mu not equal to, I don't know how to do this shit. Oh well, not equal 38. If I was in Word, I could do it. Here I can't do it. Oh well. So very last thing, I said we're just going to do this first one. Can somebody tell me, all right, that's even better, Chris, I like it. Can somebody tell me, is this going to be a 1 or a 2-tail test? Definitely a 2-tail test, because what would show evidence that it isn't 38 is more than 38 or less than 38. So it's going to look like, you know, it could even look better than that if you're better, but it's going to look like that because here's 38 and we think it's not equal to 38 in the H1. So I just need to show up, weigh the shit out there or weigh the shit down there. All right, that's going to have to be enough for today. So go check out all the stuff I've posted to Canvas related to this, start doing some examples. Check out the practice test thing. I have the YouTube video up that kind of talks about the problems. And later today, I'm going to post to Canvas the answer key for that practice test. You guys with me? So the first side of that practice test is related to the quiz that's happening on Thursday from chapter 8. All right. Any questions? Go faster. I'm sorry. You could leave. Any questions? If you don't have any questions, you can leave faster. Okay. All right. Let me stop sharing my screen. Who will leave last? Oh, Alex, we never find out because I leave before the last person. Anything else due for points this week? Always homework. Thursday's quiz is on chapter 8. That's right. Yeah, you guys hopefully are continuing to do homework and uploading the homework. I'm slowly working my way through it. You have quiz and test corrections you can still do. Yeah, so you always have something. Okay, so not seeing anything else, I am going to shut things down. I will see you guys later. You are welcome. Bye, everybody.